If I ask you what is the similarity between a sugar grain and a diamond, maybe you'll say that they both are lustrous. And what if I ask you the similarity between a diamond and a graphite? A graphite is just this piece of black stone used in laboratories. Maybe you'll think there is no similarity. Is there really no similarity between these two? The answer would surprise you. There is something common between all these three things. I'm referring to the element that these three are made up of. I'm referring to carbon. Wait a second. Are we saying that the sugar, the radiant diamond, and graphite are all made up of carbon? Absolutely. In fact, diamond and graphite are almost pure forms of carbon. They are majorly made up of carbon with a few minuscule elements that come as impurities. But how can there be so much difference in the looks of different materials made up of the same element? How can it be possible that the substances made up of the same element, carbon, appear totally different? And wait, they also have different chemical properties. The looks are different, the chemical properties are different, but they're made up of the same element, carbon. Is this some kind of magic? Well, the magic lies in the element itself. The element carbon has several interesting properties, and that's what makes it special. It is capable of forming bonds with most of the elements. That is the reason why carbon compounds are quite commonly found everywhere. But did you know that carbon is actually present in very small quantities in the Earth's crust and also in the atmosphere? That's the irony. In spite of being present in almost every compound around us, carbon accounts for almost less than 1% in the Earth's crust and in the atmosphere. But have you ever wondered what makes carbon so unique? What gives carbon the capability to have so many different properties? Let me give you a hint. Can you tell me what are the chemical properties of elements based on? Yes, they are mainly based on the atomic number. The atomic number is the number of protons in the atom. And why is it so? Because the number of protons in an atom is equal to the number of electrons in it. Right? And electrons, valence electrons to be precise, are the ones that participate in chemical reactions. So is number of electrons in the outermost orbital our answer? Absolutely. The chemical properties of an element are based on the number of electrons present in its outermost orbit. We know that the atomic number of carbon is 6. That means the electronic configuration of carbon is 2, 4. Now let me ask you a question. Look at the atomic structure of the carbon atom. To achieve stability, will carbon take 4 electrons or will it donate 4 electrons? Well, the simplest way to achieve the octet state will be by sharing electrons. This gives us the answer to many queries. Yes, the fact that carbon can share its outermost electrons with any other element gives it the capacity to form chemical bonds with various other elements. Now let's meet in the next video wherein we will learn about the covalent type of bond. Then we will move ahead to learn more about the bond formation seen with carbon.